G'day chemistry students, in this video we are looking at dot point 7.5.3 again, and in particular we'll be focusing on how to prepare an ester. Let's get into it. Now, one of the first steps that you're going to be doing is combining your selected carboxylic acid and alcohol and getting them to react. Now, when you place a carboxylic acid and an alcohol together, they're not really going to start just producing an ester immediately. The reaction isn't spontaneous, certainly not at room temperature. So what we need to do is set up a reflux system. What that means is that we have a flask at the bottom with all of our reagents. We're also going to have to put some acid in that acts as a catalyst. So the acidified mixture are present at the bottom and are being heated. That heat is going to allow the mixture to exceed the energy of activation and for the reaction to begin to proceed. However, if we begin to heat and boil flammable carboxylic acids and esters, what we're going to find is that those flammable vapors are going to start to go absolutely everywhere, especially when we boil. So one, that's a safety issue in terms of having flammable vapors in our room. Second, that could be dangerous inhaling some of those substances. And third, it's also going to mean that we're going to end up losing our product at the end. Now, a simple suggestion could be, well, why don't we just cap the top of it? That seems like a pretty straightforward and easy way of ensuring that we don't have vapors go everywhere and that we don't inhale them and that we don't lose product. However, if we just put a cap over the top, we're going to expect that gas to build up until there's enough pressure to release the cap that we've put on top. If we've put a really tight seal on that, then what's going to happen is that is going to be quite explosive, and either the cap's going to go first or the glassware is going to go. None of these options seem particularly viable. What we can do though is a reflux process where instead of putting a cap, we put a condenser on. Now, we've used this condenser for distillation before. Essentially, you have continuous running water on the outer tube, and in the inner tube, what you have is a connection to the flask where the gas can actually rise up. And the aim of the condenser is to cool down that gas, turn it back into a liquid, and allow it to drop for further boiling and further reaction. Note as well that the top of the condenser is still open. What this will allow for is the reduction in pressure buildup. Essentially, if any gas is able to reach the top, rather than getting trapped and building up pressure, it will just release. Hopefully, if the condenser is working effectively, then we shouldn't see a lot release. This should mean that it should be safe in terms of flammability and inhalation. However, this is a fail-safe just in case we do end up seeing any buildup of pressure. Once we have completed our reflux step, what we're going to expect to see is the formation of an ester, but what we might also have is an excess of some of our reagents as well as other contaminants. Now, we're going to be doing a series of rinsing steps, and what that means is the addition of a bunch of different solvents and chemicals to remove some of those contaminants that aren't the ester that we're looking for at the end. And a lot of the time, what this is going to mean is that when we start adding other substances or solvents, we're going to end up forming an aqueous and an organic layer. What this means is that one is polar and one is non-polar. They aren't soluble, and they separate out into two different layers because one is denser than the other, the denser substance sitting at the bottom. We can use a separating funnel like the one that is shown here to be able to release the denser layer into a beaker collected at the bottom of the funnel, and then use the stopper to turn it back to closed once we hit that line, effectively separating the aqueous and organic layers. Once we go through all of our cleaning and rinsing procedures, what we should have is a pretty near pure ester that we have been able to produce. Thank you very much, everyone. In the next video, we're going to be spending a lesson looking at something called surfactants. Essentially, what they are soaps and detergents. In this lesson, we'll be exploring how organic chemicals can be used to make a non-polar substance soluble in a polar substance or vice versa. But until then, have a good one.